İngilizce olarak devam edecek olan COP26 ve iklim değişimi ile küresel mücadele panelimizle devam ediyoruz.
Thank you very much, Süreyya Hanım. Dear colleagues, distinguished colleagues, you're welcome again. I kindly invite Professor Dr. Hüseyin Toros to continue and to chair the sessions. Please, Professor Toros, are you here?
Sorry, I am here. Okay.
Yeah, Professor, you're welcome. It is really great opportunity for us to continue this session in the first parts of our forum. And you're welcome again. Professor Toros is one of our colleagues in Istanbul Technical University Meteorological Department, and who is specialized in atmospheric sciences and meteorology, mainly involved in numerical modeling and air quality. And for 3 years almost, he has a great efforts on the establishment stage of Istanbul Technical University Professional, Technical and Anatolian High School in Ortaköy. So he had too many papers in the air pollution and some previous other admin efforts at the Istanbul Technical University. So Professor Toros, you're welcome. Please, you should chair the first 3 participants. Later on, I try to go ahead. Thank you very much.
Thank you very much. Dear participants, welcome to COP26 and International X for Climate Change section meeting. As you know, we have been producing continuously since 1850s, and our comfort life is increasing, but these developments have brought environmental problems. We are faced with a global problem like climate change and depending other hazards. We can solve this problem together. We can increase efficiency and we reduce waste. I hope this kind of studies will benefit for protect our environment. Dear participants, in the section, 6 different variable experts will make their presentation. We want to begin with Mr. Selahattin İncecik. I want to give some information about Mr. İncecik. He graduated, undergraduate ITU in 1971. He finished his PhD also in ITU. He studied for postdoc in Pennsylvania State University, and he will present. He is a professor in ITU in 1996 since. He has research in atmospheric science like air pollutions, ozone, and modeling. He has a lot of projects supported by NATO, Turkish Scientific and Technical Research Center, ACM, İSKİ, Ministry of Environment, Urbanization, Climate Change. He has a lot of international members like Editorial Journal in Atmospheric Science, Acoustic Remote Sensing Executive Board, NATO ITM Air Pollution Modeling member, International Society Engineering Education National Committee like. He has awarded Nobel Prize 2007 due to his studies chemicals, radioactive effects of halocarbons during Intercontinental Panel on Climate Change special report. And now Mr. İncecik will give, he present the subject is recent developments in short-lived climate pollutants. He is my teacher also. We have together do a lot of studies. Thank you, Mr. Selahattin İncecik, for their time. Now the screen and the microphone for you.
Thank you very much, Professor Toros, for your kind words. First of all, before starting my words, I hope, and we hope also, humanitarian tragedy in Ukraine will be ended as soon as possible. Now, I want to thank to Professor Zafer Aslan for her invitation to this important forum. Now, in this 20 or less minutes, I will talk about different topic in air quality and climate cross-section. This is the recent developments in short-lived climate pollutants. In this contents, I will talk about the climate change and WHO and lived climate pollutants in the atmosphere, strategies, and black carbon, climate, health, ozone, methane, and the HFC, and also the mitigation efforts, and the coalition idea is the first time, and finally conclusion. As you know, as the climate change, Paris Agreement to reach this agreement, the goal of limiting warming 1.5 degrees or even 2 degrees, as you know very well, and the last COP26 meeting, many contributions are above this level. Now, rapid reduction of carbon dioxide emissions, we know that it is absolutely necessary, but will not in itself be sufficient, because if we look the contribution to warming, you may see carbon dioxide, methane, VOCs, halogen gases, and black carbon, nitrous oxide, and others. You can see from the IPCC 6th assessment report all these warming and all these gases contribution to warming. IPCC special report, the impact of 1.5 centigrade stresses that deep reductions in emissions of non-carbon dioxide sources, particularly the air pollutants, for example, methane and black carbon, are also critical. If you look to radiative forcing and warming characteristics from IPCC report, we may see easily here carbon dioxide and methane and others at the right hand, including black carbon, but the other one is indicating especially or and others at the left-hand side. So if you look the CIMIT table, radiative forcing by emitted compound over 2015 to 2011, carbon dioxide is the first one for the effective radiative forcing, watt square meter, 1.68. But the second one, methane, is very important, closing to 1. And other greenhouse gases and black carbon and other followed. In 2018, the first WHO Global Conference on Air Pollution and Health was held in Geneva. I was attended this conference, and during this conference, the key result was announced by the general director, who approximately 7 million premature deaths annually are due to effects of air pollution, and 4 million of ambient air due to the ambient air or outdoor air pollution. So it's very important figure, especially for elderly people and children are vulnerable to the impacts of air pollution. Let's look the other face of the problem. Now, we know that the short-lived climate pollutants in the atmosphere is a very new topic because of black carbon, for example, along and tropospheric ozone, and some HGFCs is responsible for 1/3 of current global warming. These pollutants also have adverse effects on public health and the environment. And short-lived climate pollutants stay in the atmosphere for a shorter period, unlike long-lived greenhouse gases. For example, black carbon stay between 4 and 12 days. Methane is 12 to 15 years. Also, tropospheric ozone, several days. I'm talking the ground level ozone, not the stratospheric ozone. And there's some hydrofluorocarbons, it's about 15 years. And deep carbon dioxide reductions are required to protect the climate in the long term, but the situation is different for short-lived pollutants. Strategies on this, the key strategies for the global fight to reduce greenhouse gases refer to large-scale energy efficiency and the use of new technologies. For example, climate policies under UNFCCC cover the climate impact of aerosols, including the black carbon and ozone, in long-lived greenhouse gases. So this situation requires the different evaluation of the emission reduction strategies for the short-lived climates pollutants and implementation of strategies. Now, if you look to the problem by reducing black carbon and methane, it will also slow down the expected warming by 0.5 centigrade degree until 2050. It's very important figure and level. If you think the 1.5 centigrade, about 7 million, in additionally, about 7 million premature deaths will be prevented each year, according to WHO. And also it will be possible to prevent annual product loss of up to 30 million tons. And if you look at the short-lived climate forces and carbon dioxide, there is a warming effect by carbon dioxide, it's clearly seen here, and methane also, and the black carbon also, and ozone. But the other nitrate, organic carbon, and sulfate and cloud indirect effect on the negative part or cooling effect. After this reality, it is predicted that of climate pollutants in increasing global warming may continue for many years. However, will be an opportunity in terms of their impact on global warming. An additional warming effect will be created by accumulation of black carbon on snow and ice, especially in Arctic area. Mitigation of short-lived climate pollutants, this reduction will have positive co-benefits for climate and air quality and agricultural production and human health in the near term. This coalition, this is a typical coalition. This coalition identifies the 4 immediate areas of action. The first, reduction of BC from heavy tonnage diesel, especially diesel vehicles. The second, reducing these pollutants in the HFC, and finally acceleration in the reduction of methane and black carbon and in oil and gas production. If you look at the black carbon, it is a typical component of particular matter. And if you look, if you remember the PM1, PM2.5, and PM, and this family can be addressed in black carbon. About 19 of global emissions come from the transport sector. So the transport sector is the key sector to mitigate the black carbon. And the most effective absorptive aerosol in the visible spectrum absorbs all wavelengths of the solar radiation. Black carbon is a component of fine particulate matter. I mentioned what PM1 means that the diameter of the particulate 1.0 and less. Black carbon consists of pure carbon in several linked forms. It is formed through the incomplete combustion of fossil fuels, biofuel, and biomass, and is one of the main types of particle in both anthropogenic and naturally occurring soot. And when we look globally, this problem, especially for transportation, diesel vehicle should be mitigated from the globally. When we look at the spatial variability of the black carbon in the worldwide, Asia, Africa, Latin America contribute about 88% of global black carbon emissions. You can see from graphics, and the red points indicates the locations and the countries. Another view, most of the emissions are from developing countries. So East and Southeast Asia, Central and Southern Africa, and partly in some of the locations. And I want to skip here. From the IPCC 2007 report, radiative forcing of black carbon from fossil fuel is plus positive 0.2 watts square meter figure, and the additional radiative forcing of BC through the effect of snow and ice on the surface albedo is the positive 0.1 watts per meter. After carbon dioxide, the black carbon emissions make the biggest contribution to global warming. So the reduction of black carbon will be very important to affect the climate. And the transport sector, the coalition's heavy-duty diesel vehicles and engines initiative works to catalyze the major reduction in black carbon through adoption of clean fuel and vehicle regulations and supporting policies. So a forced focus on diesel engines in all these figures indicate the importance of the transportation, about the 3.2 million deaths per year and 19% of black carbon. So for the health view, about the 300 to 700,000 premature deaths in 2030 are expected. And black carbon, excuse me, now the second important key issue is the methane. Methane is 25 times more effective than carbon dioxide. 60 to 70% of methane emissions occur as a result of the human activities, production, storage, and transportation of oil and gas industry, agriculture, and waste management are the main sources, especially with the livestock producing about 31% of global methane emissions. You can see from this picture, from naked eye, this is a typical petroleum storage tank. But if you use the infrared camera, you can see the methane easily. The methane concentration has also increased by about 150% since 1750, while its share in the total radiative strain has been 20%. So the methane emissions are predicted to increase by 20% by 2030 if the aggressive reductions are not implemented. You can see easily the methane emissions is still increasing. Well, the question is how to reduce the methane emissions. There are several answers, possible answers. One is renewables of systems used in the production, storage, and the transportation of oil and gas in coal mines, and can be reduced also from livestock operations of animal feeding practices. And the garbage is a major source of methane waste. If you look at the waste management to the problem, capturing methane in landfills in an effective mitigation strategy. And the third one is the ozone. Ozone and climate is very jointly as a joint behavior. The third most important greenhouse gas after carbon dioxide and methane is ozone. Its long-term value with its global impact is a problem, and long-term ozone concentration are mostly determined by global methane emissions. So there should be a linkage, and the global ozone is gaining in importance here. If you compare from a study published in 2020, ozone and economical loss relationships are very important. Ozone damage plants and leads to about 11 to 18 billion US dollar worth of crop losses each year. This is important, especially for Northwest Europe, in European continent. Here, by acting on climate and air pollution, together we have the opportunity to take advantage of synergies between the Paris Agreement, climate goals, and the United Nations Sustainable Development Goals to improve lives now, limit future climate. So human source emission variation in 2030 using the base of 2005 indicating are very interesting by using large scale transport, agriculture, industrial process, and the waste sectors especially. HFCs are man-made greenhouse gases and are used in air conditions, refrigeration, and solvent making, foam materials, and aerosols. Many HFCs can remain in the air about 15 years, although less than 1% of existing greenhouse gases is extremely high, and the coalition partners seek to reduce HFC emissions, strive to spread climate-friendly new alternative gases. Benefits of reduction of all emissions. Now, if you look from the all emission view, if the measures are implemented by 2030, the global temperature potential increase predicted for 2050 could be halved according to reference scenario based on the current policy in. So the amount of regional temperature, the increase also decreases. Now, what management is needed on this point? UNFCCC Long-Range Transport Pollutant Convention, Gothenburg Protocol, it was renewed in 2012, Regulation of National Emissions, and Climate and Clean Air Coalition was by 6 countries and UNEP in 2012. The Climate and Clean Air Coalition has a target realizing benefits of climate, health, food, and energy by reducing short-lived pollutants. This is a new global, and the preliminary studies on a voluntary basis, 2000 in Mexico, it was established after establishing this, new participants, especially this coalition, expanded to 37 member countries, and EU was included. Now the number 94 as of May 2014. Those are the member countries. Conclusion. Multiple benefits of climate, air quality, health, and sustainable, aside from contributing to limiting global warming, strong reductions in methane, black carbon, and the ozone have other for sustainable development. So they protect health and avoid premature deaths by improving air quality. And in addition, the crop losses, they can prevent the climate from reaching tipping points. So long-term climate impacts and make adapting to climate change harder, especially for the poor and most. And carbon dioxide, both carbon dioxide and air pollutant should be taught together for designing selecting climate and air quality measures. Now, some technologies that are promoted as climate-friendly combustion of biomass and other biofuels for home heating or transport, for example, particulate matter, including black carbon, then the technology it replaced, then continue to harm human health and the potential warm climate. And from now on climate change and equality will be considered together. English, the 18th World Clean Air Congress was held in 24th to 27th of September 2019. I want to thank, I hope my time.
Thank you very much, Mr. Selahattin İncecik. You have present very nice and valuable presentation about the subjects. We have no time, so we will continue presentation other subjects. You can ask your questions, Mr. İncecik, via email. You can see İncecik's email in chat. Now, Mr. Professor Abdel Wahab from Department of Meteorology, Faculty of Science from Cairo University. His studies characterization and impacts of heat waves in northern and southern Mediterranean basin. Before his studies, I want to give some basic information about He is working as a professor at the Cairo University in Egypt since 1977. He studied his PhD in atmospheric science and dynamics, Moscow Institute of Physics and Technology. He studied his master's degree in atmospheric physics and dynamics in Cairo University. He studied a lot of subjects in atmospheric science. He specializes in weather modeling, climate change, air pollution. He is currently teaching and consulting in the field. Principal investigator and co-director many scientific projects, including establishment of the Earth Observation Satellite Data Receiving Station at Cairo University. Established Climate Research Laboratory at the Faculty of Science, Cairo University, to model climate changes over the Middle East and North Africa. Conducted a project in Nile Basin Precipitation and Early Warning System of Flash Floods with National Forecasting Center, Ministry of Research and Irrigations. Mr. Abdul Wahab is not now in the meeting, so his studies will be presented Mr. Zafer Aslan. Mr. Zafer Aslan, please, screen and microphone for you.
Dear Professor Toros, thank you very much. I would like to keep the time because we have almost 1 hour delay from the firm schedule of our conference by considering all the patience of our participants. I try to present his paper, Professor Wahab's paper, on behalf of himself. We met with him at International Theoretical Physics Center in 1990s. He was one of the associate research group there. So still we have some ongoing activities together with Professor Wahab and his students. So in this speech, unfortunately, he would not be able to join with us with the other reasons, sudden changing. So his presentation is related with the characterization and impacts of heat waves in northern and southern Mediterranean basins. So if I go down, the data where they and his co-authors had been considered related with the atmospheric parameters, and they applied some regional models like COSMO, 45 and 80. So they just consider 5 individual stations, local area like Daba, Matruh, Harogada, Cairo, and Aswan. So they also consider long-term data registered at the Meteorological Organization beginning from 2005 up to 2040. So by considering the methodology, they had taken into account different kinds of the indexes, like annual number of days when temperature is more than 20 degrees Celsius, warmest daily temperatures for every year, and coldest daily number of days, and the mean differences between daily maximum and the minimum temperatures, and the annual number of days with at least 2 consecutive days when temperature is less than 10 percentile, if they consider the all total number of days. And percentage of days, if it is more than 90 percentile, they also consider. And when the days less than 10 percentile, it is also included. And heat wave magnitude, the mean temperature of all heat wave events is another indicator, and the amplitude also another indicator, and heat wave numbers, their frequency is another essential indicator, and duration also, length of the longest heat wave events in that latitudes, and the heat wave frequency and cold wave numbers. They are all indicators which they have been considered to apply their methodologies. And if you look at the general results, here we have noticed some simple time series analysis, including the linear trends. As you see here, the first station in Matroh and Daba and Aswan, and also Cairo and Hurghada. So they have the serious increasing trend in Aswan, Hurghada, even in Cairo, but a little bit less gradational trends in last two stations. And if you look at the cold wave numbers, they have recognized that the decreasing trends in first three stations, three study areas. First one is the Daba, and then Matruk, and then Aswan, but slightly increasing have been observed in Hurghada, and important increasing have been observed in Cairo. So if you look at the conclusion, they have summarized the heat wave frequency and duration. These two variables have been increased for all stations. And this is very important results of the study areas, and number of discrete cold wave events decreases at all stations except Cairo and Hurghada. They shows the different behavior according to the reanalysis data. And what about the remark? They still go ahead for their studies by considering the different models, regional and large scale models at the study area available at Northern Mediterranean. And still their study is going on. So Professor, thanks for your all attentions. If you have some questions, we can forward your questions to the email addresses where you see here. Thank you very much, Professor Torres. Thank you very much, Professor Wahab, for important presentation, joining with us with his presentation and with his group. Thank you. Professor Torres, we cannot hear you. You should open your voice, please. Professor Torres, we cannot hear you.
Sorry, I can't open the microphone. Thank you very much, your presentation. Again, we have no time, so is there any question? You can connect with Wahab via email. I write his email to chat. Now, the other subject, assessment of expected changes in bioclimatic variables over Marmara region and their impact on Marmara forest. This study will be done by Yurdanur Ünal. He is a professor in atmospheric science in ITU. She is working in ITU since 1984. She studied his master's degree and PhD degree in USA in atmospheric science. She is working as a professor in ITU since 2012. She has a lot of studies in atmospheric science, atmosphere, ocean interactions, climate changing modeling, meteorological disasters, climate scenarios, regional modeling, Cosmo, European Wind Atlas projects, many others published in the rated journals. Mr. Yurdanur Ünal, now microphone and screen for you, please.
Thank you very much for a nice introduction, Professor Torres. I would like to start my talk by wishing peace for Ukraine, first of all, and then let me share my screen first. Sorry, this one. Is everyone able to seeing the slides?
Yes,
right?
Yes, yes.
Okay. The title of my talk, as you mentioned, assessment of expected changes in bioclimatic variables over Marmara region and their impacts on Marmara forests. Right? This is a collaborative research we are doing currently, and the people are working on this. The list of people are given in this slide, actually, working on this project. The institutes like Istanbul Technical University, Karadeniz Technical University, and Marmara Forest Research Institute are collaborating on this project. Okay. Now, let me start with a little bit motivation. All right. we know that global climate change has already an observable effects on our environment. Like we see glaciers have shrunk, ice on rivers and lakes is breaking up earlier than before. Plants and animal ranges have shifted to the higher latitudes or higher altitudes, and trees are flowering sooner now, right? So the observations shows that the global average temperature has been increased 1.2 degrees Celsius within the last century, and the Intergovernmental Panel on Climate Change, shortly IPCC, forecast a temperature rise of 2.5 to 10 degrees at the end of 2100. So that means the average temperatures are increasing, but at the same time, of course, precipitation regimes over the globe is changing. Right? It is well known that the rate of temperature change will increase. Levels of greenhouse gases in the atmosphere is amplified at high altitudes as well, and high latitudes, sorry. And for example, polar regions will warm faster than tropical regions. And even we see these sort of temperature rises nowadays, all right? What else? So as we mentioned earlier, since the warming is not evenly distributed over the globe, all right? Some regions will have warmer conditions than the other regions. So especially when we focus on the geography in which our country is located, like Mediterranean basin, this Mediterranean basin is one of the important climate change hotspots due to the pronounced warming and drying projected under the future emission scenarios, right? So that means regions' climate is especially responsive to global warming, and it's exposed to the greater risk of climate change, right? And we know that the increase of 2 degrees Celsius temperature, global temperatures, compared to the pre-industrial levels, might have really serious impacts on the natural environment and human and health, and also well-beings of the human beings, right? Countries try to fight, of course, against the increase in our carbon dioxide and put into some practices or some practice mechanisms in order to cope with the Paris Agreement, actually, and try to limit the increase of global temperature under 2 degrees Celsius. So what we are doing first, we are trying to, as climate scientists, we are trying to understand how this climate is going to change in the future. And in that sense, we are using the climate models, right? Like long-term forecasters, right? But when we consider the global climate models outputs, we see that their resolutions are pretty coarse, and then it is not usable in order to do the impact analysis in regional scales. So that means regional high-resolution climate projections are essential in order to address the impacts. And another issue is the long-term effects of climate change will be seen on the forest areas. Like that means, for example, adaptation in forests to climate change is required for substantial forest management. We know that the currently Earth's forest and soil absorb about like 30% of atmospheric carbon dioxide emissions, and partially through forest productivity and restoration, right? So that means that planting new trees is one of the most effective ways to reduce atmospheric carbon dioxide and limit global warming. Right? So, and some of the studies show that the ecosystem could support like another like 900 million hectares of forest area. So that if we plant those areas with the forest trees, and then at least we can reduce 25% of the emitted carbon dioxide to the atmosphere. Right? Even the problem is even once the trees are planted, it will make them take a century to grow, all right, to reach a maturity. Then we need to be carefully implant the trees. See, we need to understand what type of trees are survive or can survive for the future climates or for a certain regions, all right? Or that it's very crucial to find out which climate conditions will occur, first of all, in the forest areas in the future, and also which tree species will be more adapted to survive on these conditions. This is the main topic of my talk actually here. And I'm going to just briefly explain what are the methodology we follow. We first try to do regional climate modeling. We select the Earth system model from the CMIP5 models, and then by using the worst case scenario RCP 8.5 scenario, which means it indicates, this scenario indicates that at the end of the century, the greenhouse warming or human being influence on the atmosphere is going to cause a kind of 8.5 watt per meter square forcing on the system. So what we are doing, since the Earth system models have large grid resolution, we just downscale it to the smaller scale, like through these steps by using these ranges. And then our focus is the Marmara region, which is shown in this inner square with this plot. All right. So, and then after doing this regional downscaling of the climate simulations, global climate simulation, we use species distribution modeling. In this case, the model is used is the maximum entropy modeling of species geostrophic distribution developed by MIT. And what we give to the model is the topography and climatic data. This can be current conditions or future conditions under different emission scenarios. And generally, we give these bioclimatic variables into the model, and then model predict the species distribution. Of course, these are the models define which species are going to be interested to do the analysis, all right? So like eventually we obtain some results about the species distributions, right? Sorry. And what we do, we do the analysis for the current climate conditions, and then obtain current species distribution, and then compare it with the current distribution, all right, with the observations actually, and then do the future climate simulations, and then run the maxent for future climate data, and then estimate future species distribution. All right. Now, let me give a brief results about what we obtain. Since we have really high resolution simulation, which are in the order of 2.8 kilometer resolution, all right? So that means we have really highly represented topography over the region and land use cover, because that the local climate depends on the topography and land sea contrast and land cover distribution, which alters also, especially the large scale atmospheric flows. Therefore, we concentrate on the high resolution simulation, because when you look at the Marmara region also consists of all sort of different features of topography, like land sea distribution and topographic barriers around. So what we did, we simulated annual mean temperature, and then for the future conditions under RCP 8.5, for example, 2031, 2040 averages are shown here for decadal periods. As you see, temperatures temperature range is from lowest to highest, from blue to reddish colors. As you see, when we go through the end of the century, the temperatures are increasing. Like, for example, at the end of the century, we observe like temperatures, average temperatures, annual average temperatures is around 28 degrees Celsius, all right? Sometimes at certain locations. And if you look at the differences, all right, for example, for the first period, the difference is only 0.67 degrees Celsius. This is the average over the Marmara region, all right? But however, when we go to the end of the century, the temperature increase is going to be 4.62 degrees Celsius. These are only corresponding to mean temperatures. So depending on this structure, the distribution of temperature, of course, the extremes will be even higher in the future. All right. So if you look at the annual total precipitation, this shows the current conditions, and the others are corresponding to the future expectations. For example, when we go through the end of the century, you see the reddish colors decreases, which means the precipitation decreases over the regions. However, when we look at the northern latitudes, you see at the northern latitudes, we see slightly increasing precipitation, all right? If we look at the average values, all right, in terms of percentages, for example, in the coming decade, in 2031 and between 2031 and 2040, precipitation will decrease only 3.3%. But however, when we go to the end of the century, the last decade of the century, the precipitation degrees will be like 23%. All right. So these are quite large variability in terms of temperature and precipitation. And if, sorry, what happened? So I'd like to give the calculated bioclimatic variables. I'm going to just give you some a sense of these results, all right? All numbers in this table correspond to the averages over the Marmara region. As we mentioned, annual mean temperatures are increasing, but at the same time, if you look at the warmest month temperature, maximum temperatures, they are increasing as well. As you see, a mean temperature increase is 4.6 degrees Celsius at the end of the century. However, when we look at the warmest month's temperature, maximum temperature, it is 6.3 degrees Celsius, at least 2 degrees warmer than the average conditions, right? So that means these are going to affect the biological cycle over the forest areas, right? And also similarly, coldest month temperatures, minimum temperature is going to increase. As you see, coldest months temperature are increasing a little bit slowly than the warmest month. And this important actually, wettest quarters mean temperature is going to increase more than the average, which is 5.8 degrees Celsius. What does it mean? It means that since we have wettest quarter, that means we are receiving precipitation with the high temperature, evapotranspiration is going to increase so that the soil is going to deplete in terms of moisture. This has a kind of effects on the biological system, all right? And if you look at the precipitation, all right, for example, annual precipitation is changing like 22%, decreasing actually 22% at the end of century. But if you look at the wettest month's precipitation, the wettest month's precipitation is decreasing slightly lower than the amount. That means still when we compare the wettest months generally corresponds to winter season over Marmara region. So the winter season's precipitation is going to decrease lower than the annual precipitation rates. But what happens actually, driest months precipitation decrease severely, like 80%. We receive very little precipitation during the summertime over Marmara region, but the result shows that we will not have any precipitation at all in the future. What does it mean? It is that the soil is going to be very dry, and then it is going to create a kind of environment for the severe heat waves, all right? Or heat waves impact will be really large on the habitats, all right? So we did some analysis for the habitat suitability of some species in Marmara regional forests. This shows different species suitable areas over Marmara actually for different time periods, as you see. And also in the next slide, I'm going to show how which areas are going to create a kind of suitable environment for forests, and which are changing through time under the climate change. For example, in 2031 through 2050, you see these brown colors corresponds to the change areas, all right? And if you look at this 2071, 2021, you see the change areas are getting larger, all right? So that means eventually certain regions of the Marmara is not going to be suitable for certain type of species, all right? Now let me go to the conclusions. For example, our high resolution climate projections for Marmara region suggest that average annual mean temperature increases till 2100, and the warming at least at the last decade reaches to 4.6 degrees Celsius. Temperatures on the land areas adjacent to the seas remain at least half degree cooler than inlands in the future, all right? The maximum temperatures, for example, daytime temperatures, and are warming faster than the minimum temperatures, nighttime temperatures. And maximum temperatures of the warmest month rise up to 8 degrees Celsius at the end of the century over inland regions, and specifically on the southern latitudes coinciding with the mountain regions like Uludağ, Sündikan, and Köroğlu mountains and their surroundings. And if you look at the precipitation results, increasing dryness and seasonal variation of precipitations is detected over the region. The annual precipitation decreases up to 23% at the end of the century. That means the region is going to dry. But however, when we look at the latitudinal variations, we see that northern latitudes and land areas along the Marmara Sea receive precipitation more than current conditions in the near future. But this monthly total precipitation declines 10% at the end of the century, with the largest degrees occurring over Kaz Dağı, Uludağ, Sündikan mountains, and on high elevations of the south of Balıkesir province. And precipitation amounts for driest and wettest quarters, and for warmest and coldest quarters decrease more than 50% over till 2100. So if we combine these effects with the species distribution by using the species distribution modeling for Marmara region, and our results suggest that mixed forest and, for example, Meşe, Quiscus species will have more suitable areas in the future over Marmara. So the habitat suitability of many Pinus bruta, Pinus nigra, and other species will persist by 2100. So what it says, actually, our results suggest that by using these sort of analysis, we can estimate which type of species are going to survive for the future under the future climate, and accordingly we can determine what to plant nowadays, because each planted tree will should survive at least 50 years and more than 50 years, so that we need to consider how climate change is going to affect these species. Thank you very much.
Thank you very much.
I am done. I hope I'm...
Professor Yurdaner Ünal. your variable studies, nice presentation. Thank you very much. Again, time limitation. You can ask for participants. They ask the questions to you via email. Thank you very much.
So, dear Professor Toros, thank you very much for your chairing the first three important and dear participants and presenters for invited talks. So I kindly invite Dr. Mamta Agarwal. I think she is with us. Mamta?
Yes.
Yeah, Mamta, you're welcome. Hello.
Yeah, thank you.
It was nice for us to meet with you. I just tried to introduce you. Meanwhile, you can share your presentation, please. And Dr. Mamta is from Bhopal University in India, near vicinity, and she is specialized in mathematical modeling and senior assistant professor. She had her PhD at the Department of Mathematics, Maulana Azad National University, Technology University in Bhopal. She has also, some different projects under the shame of women scientists in New Delhi, and principal investigator more than 17 years, involving in teaching and research experiences. And she had done some different collaborative projects together with Indo-Austria and Manit projects, and she had many national and international papers published in SCI journals, and she had also cooperation in between South Korea, Thailand, Austria, and Nepal. And she is board member of the different deputed journals, and her research interest is related with the applied maths and computational biology. And it is really a great opportunity for us. We had a memorandum of understanding in Bhopal University and Istanbul Aydın University almost for 3 years. Beginning from the pandemic. So we had ongoing online internship programs with guiding by Dr. Mamta. And we are very happy to join with her graduate students to prepare some research papers. Last year, we had a great chance to work together with Ms. Maimansha. Unfortunately, she wouldn't be able to join with us. And so really, we are going on with 3 more young colleagues at the graduate programs at Bhopal University this semester until June, we will go ahead. So Professor Mamta, you're welcome. Please, it is your turn. Thank you very much for your participation.
Thank you so much. Thank you so much, Professor Zafar. So first of all, many thanks to the organizer team members of the webinar of International Climate and Energy Forum, organizing in Istanbul Aydın University, Turkey today. And a special thanks to Professor Jafar Aslan to invite me and giving this opportunity to be here with you all. And thank you once again. So my talk is about the effect of climate on human health. So as Professor Zafar already told, my research area is generally based on the mathematical and computational biology. So this topic is based on that particular area, and my research scholar is also working on this particular topic. So just I'm starting. Is it visible to everyone?
Yes.
Yeah. So this is about the introduction. Yes. So since the presentation is about the climate effect on the human health. So what happened? Let's see. Climate change refers to long-term shifts in temperature and weather patterns, and these shifts may be natural, but since the 1800s, human activities have been the main driver of climate change, and primarily due to the burning of fossil fuels like coal, oil, and gas, which produces heat-trapping gases. And climate change is already impacting human health. And there is very much effect of the hot and cold climate on the human body and human temperature also. So changes in weather and climate patterns can put lives at very risk. So heat is one of the most deadly weather phenomena. As ocean temperature rise, hurricanes are getting stronger and wetter, which can cause direct and indirect deaths too. So the main objective here to assess the factors of the climate change and what are the effects of the climate on the human organs and especially on the body temperature. So let's see what are the effects, main effects of the climate change on health. The main effects on the climate, this particular model is totally applicable and support the platform for the decision at the local scale, considering the effect that climate change might have on human health endpoints and investigation of the effectiveness of the mitigation options. So this desired model consists some capable of addressing multi-stressor effects on the human population, temporarily and especially explicit, scalable, credible in assessing trades-off, and easily used and interactive and transportable also, and adaptive to the new data and information. So let's see what are the main impact of the climate change on human health. As you are seeing here, the main effect may be here like injuries, mental health. If there is very much climate change is there, so there may be health impacts, asthma, heat-related illness, death occur, cardiovascular failure, environmental degradation, extreme heat generation, air pollution may be there, increasing allergens there, respiratory allergies, asthma, malaria, dengue, so many diseases may be occur due to the climate change. So this effect on the human health. So these are the main impact which effect on the human health, in which one is main effect is thermoregulation, because what happens in the body every time heat is generated and lost. So the thermoregulation play a very important role in human body. What happens in body, we know everyone, there is core temperature. So this core temperature is very dynamic, and this temperature is 37 degrees centigrade in body. So to balance this 37 degrees centigrade, the body, there should be heat gain, there should be balance in between heat gain and heat loss. And there is mean body temperature, which represent the average skin and internal temperature also. What happens there, if the body temperature is something 37 degrees centigrade or above it, so there may be hypothalamus acts. This may occur in the body organs. And if effectives of heat loss, how heat loss? Heat loss due to the conduction, convection, and radiation. And if it increases sometimes, so the temperature of the body may sometimes increase or decrease. And due to this, the patient or the human may ill or may get some disease too. And when body ambient temperature exceeds body temperature, so heat is gained. And when it is not exceed, so sometimes heat is also lost. So these that's why heat loss and heat gain play a very important role to maintain the body core temperature 37 degrees centigrade. So the main reason from the heat by which we get the heat is the metabolic activity. Metabolic activity is the chemical reaction which occur every time in the body due to exercise, if we eat, if we walk, whatever we do, the activity, metabolic activity occur in the body, and that's why heat is gained. And heat loss due to conduction, convection, radiation, and evaporation. So let's see how human temperature regulate in the body. Humans are endothermic in nature. We generate our own body heat and have capacity to regulate body temperature. And this body temperature is influenced by the environmental, like climate change. Sometimes the climate is hot, it is cold. So there are very reasons so that our body may sometimes lose heat or sometimes may get heat to regulate the body temperature. And this body temperature has two components. One is core and shell. So the core is 37 degrees centigrade, but the shell temperature may vary according as the climate effect. So a stable core temperature is achieved through homeostatic thermoregulatory mechanism linking cold and warm receptors in the skin and brain to heat production from muscle and other organs. And in the shell, temperature measured in the skin, hands, and feet is approximately 4 degrees centigrade lower than the core temperature. But in the warm environment, if the environment is warm, climate is hot, so heat loss occurs from skin vasodilation. So the temperature decreases from the inner core, means body core, to the outer surface of the organs. So heat loss at certain conditions, heat loss at ambient temperatures and heat loss at high humidity. There are two certain conditions by which heat losses. And this is the body about the body temperature on cold days, means cold environment, on the cold climate, and versus the hot days or the hot climate. What happens in the cold day or the cold environment, cold climate, blood and skin temperature fall, and temperature receptors detect change and send nerve impulse to the brain, and then hypothalamus of the brain is stimulated and sends nerve impulses to relevant body parts, and then decrease in the heat loss and increase in heat production, increase in metabolic rate, means chemical reaction in the body, and heat is produced and the blood temperature returns to the normal levels. So in this way, in the cold climatic situation, the body temperature regulate in this way. Similarly, in the hot climatic condition, the body temperature regulate. First, blood and skin temperature rise, then temperature receptors detect change and send nerve impulse to the brain. Then hypothalamus of brain is stimulated and sends nerve impulses to relevant body parts. Then increase in heat loss, and then metabolic heat reduce here, and then blood temperature returns to the normal cells. So in this way, in the climate, a cold and hot climate, the body temperature regulate. Now, if the core temperature is less than 37 degrees centigrade, so this may be the reason of the thermoreceptors. In the thermoreceptors, the nerve, muscle shivering and more heat generated, and similarly sweat glands decreases, secretion and less evaporation occurs, muscle, skin, arteries, walls constrict, and less radiation and conduction of the heat generated in this case. But if the body core temperature is greater than 37 degrees centigrade, and this all depends on the climatic temperature, so thermoreceptors, hypothalamus condition, nerves, hypothalamus condition occurs, sweat glands increase in this situation, muscle reduce activity, and muscles of skin, arterial walls relax, and in this way, less heat generated. So heat balance equation is due to air temperature, radiant temperature, surface temperature, air humidity, wind speed, which we can find by using the mathematical model. So these are, you are seeing some results. In these results, we have developed a mathematical model, and from this mathematical model, we just find here that if the climatic temperature is very low, that is in the low climatic temperature, the variation in the temperature is more. This is the low climatic temperature here, atmospheric temperature, and the variation of the body temperature is more. This is due to the heat loss to the environment at low atmospheric temperature, while the temperature, atmospheric temperature is increasing, means in this case, the variation is less as compared to this figure. So in this way, we can conclude here that if the atmospheric temperature or climate temperature is less, the temperature of the variation of the body is just increases due to the heat loss from the heat loss to the environment. And these are also some graphs in which again the same situation. This is for the 15 degrees centigrade, 20 degrees centigrade, and 33 degrees centigrade, means different climatic conditions. So, so the conclusion here is, these are some case studies. Temperature mortality responses functions are also here. Here we analyzing the relative mortality increase for all non-accidental deaths per 10 degree Fahrenheit increases in apparent temperature. So this is the formula to calculate this apparent temperature. And this is also showing the graph here. And these are some case studies of India in which these case studies is about in 1985 in India. This figure shows the relationship between high temperature and deaths observed during this year. And the large spike in deaths in mid-July is much higher than the average number of deaths during that time of year, as well as the deaths rate before and after the heat waves. And these are some references. And the conclusion is in the cold climate, temperature variation increase due to the heat loss from the to the environment, and in hot climate, temperature variation decreases due to the heat loss to the environment. So thank you for your patience. Thank you so much, everyone.
Dear Dr. Agarwal, we would like to thanks for your very impressive and interesting and important presentation regarding with the meteoro sensibility of the human being. So if some colleagues, they have some questions, so they will directly correspond with you to keep the time. We are sorry for this. I'm sure you are so busy, and thank you very much for your participation, taking your time. Thanks a lot.
Thank you.
So the next speaker is, again, one of the invited speech, which will be delivered by Dr. Abdullah Altun. He is the coordinator of TESPAM regarding with the economic issues. You're welcome, Dr. Altun. It is nice for us to meet with you here. And he will speak about global value chains and emissions. And I just kindly share with you his academic background. Professor Altun, he had his PhD degree in 2017 at the Gebze Technical University, and he is just now full-time assistant professor at the Department of Economics at the same university, and also he is carrying on the coordinatorship of TESPAM Research Center for Turkey Energy Strategies and Policies, our main collaborative regarding with economic studies. And he has visiting scholar at the Faculty of Management and Technopreneurship at the University Technical Malaysia, Melaka, UTM. So we had also a very great cooperation in between the UTM. So they 2 times visit us every year, even during the pandemic. So we are also very happy to hear about it. And you also one of the former visitors at the Faculty of Economics at the University of Warsaw in Poland. So you are the senior specialist in informatics and information security research center in the Scientific and Technological Research Center to be TAC. So it was really great efforts, Dr. Altun. Please, you're welcome. It is your turn.
Thank you very much, dear Professor Aslan. First of all, I would like to thank the Aydın University, Istanbul Technical University and TESPAM for organizing such an important international forum. Also, I would like to convey my deepest respect and thanks to distinguished participants and audiences. I will make a short speech by focusing on very significant points, especially in terms of global value chains and emissions nexus. Recently, we witnessed really great efforts of developed nations for reducing emissions. Of course, this doesn't mean that they are innocent at all. Regarding the cumulative responsibilities of countries in current situation of the global emissions and climate, it's very clear that developed nations are account for the majority of outcomes. Meanwhile, many developing nations try to access further development targets with increasing energy needs. Even some of them become big energy hunger countries such as China and India. The question here is whether some limitations within the context of emissions will prevent them even from providing certain level of basic needs of their society and may prevent them from further development. But this approach also leaves some missing points in mind, since these emissions are calculated from the activities of nations in their own borders. Let's clarify the issue with a question: who produces for whom? my main field, global value chains, is the answer for this question. After the 1990s, the world witnessed a huge transformation in a way that multinationals of developed countries outsource their activities towards the developing nations. This production fragmentation or production sharing result in a very intense geographical dispersion of subphases of production activities. Thus, to be able to produce certain goods, various countries are involved in the process by their intermediate goods. We call it second great unbundling or global value chains revolution. As a result, both exports and final demands of countries started to include significant amounts of foreign value added. Although this implies failures of gross trade statistics, still awareness is very low. Which country produce for the final demand of which country? Now we use this terminology in new and advanced global value chains participation calculations. Similarly, if a foreign country produces for the domestic final demand of another country, who really is responsible for these emissions? When discussing the emissions and climate change, these missing points shouldn't be ignored. The taxes on emissions should be assessed from this point of view as well. Imposing a tax by European Union and USA may be on behalf of their own detriments. In 2018, the share of, I will give some examples, the share of domestic value added of China embodied in final demand of USA is approximately 23.4%, and the share of domestic value added of China embodied in final demand of European Union 28 countries is approximately 17.6%. Approximately 40% of domestic value added of China embodied in a final demand of USA and European Union countries. For India, as to India, the share of domestic value added of India embodied in final demand of USA is 24.5%. And the share of India, value added of India embodied in final demand of European 28 countries is approximately 19.2%. As you see, approximately 40% of domestic value added of each country embodied in final demands of European Union and USA. These statistics may vary regarding the share of emissions due to emission value added ratios of sectors, but at least can be a good proxy for giving an idea. Since the methodology of the life cycle assessment, which we use intensely, especially nowadays, is very similar with the calculations of global value chains participation indices. I have a bit skeptical about the real aims of Western countries recently. For example, the real aim may be to break the global value chains for regaining lost powers by USA and European Union recently, since after the 2007 global food crisis, 2008 global financial crisis, since 2018 trade wars and latest coronavirus break, all imply an increasing self-sufficiency concerns and increasing protectionist sentiments in global economic environment. Since China rises as an economic and technological giant as a result of these global value chains revolutions since 1990s, and there is an effort in USA and European Union countries to change this trend again. Three scenarios are on the table. First scenario, Western side is really aware of the increasing climate problems, and they really want to solve these problems with real good intentions. Okay, this is first scenario. But in second scenario, Western bloc tried to break global value chains, but after regaining the previous power, or after making China lose power, which I tried, actually, if they can turn the case before 1990s situations, they will leave these climate efforts. Third scenario, they have new means or equipments as a result of innovative activities. For example, United Kingdom produces new nuclear power generators, modular nuclear power generators, or some new innovations. They may have such innovations, and they may try to organize suitable economic environment for penetration of these equipments into market. Second and third scenarios are very consistent with the expected third great unbundling in global economy. That is a new algorithm of global economy, expected algorithm for very next years, with increasing capital intensity as a result of artificial intelligence, 5G, big data, machine learning, and Internet of Things. But in any way, the current situation of climate issues requires very big efforts. Before I finish my speech, I want to mention about 2 new papers of us. Very soon they will be published and I can share with participants. One of them is related with the role of global value chains in circular economy, and we mainly focus on the emissions of different countries in their trade. Emissions embodied in trade, we calculate for 189 countries, which will be published in a circular economy book by Turkish Academy of Sciences very soon, and I can share. Second one is related with the role of global value chains in outsourcing emissions, which will be presented at the end of this month. And again, if our participants can be in contact with me, I can share these papers with them. Thank you very much for your listening. And I am finishing regarding the time restrictions.
So, our colleague, Dr. Altun, it was really interesting speech. Thank you very much for your informative sharing with us. And now we will share your emails. If there were some contributions and some questions, you will have these details. Thanks again for your valuable contributions.
Thank you very much.
So the forthcoming paper will be presented by Mrs. By Mrs. Roka. Shall I produce Rokaya Mohammed Hassan? Rokaya, are you here? I think you were here. Yeah. Yes, please. You're welcome. It was nice for us to meet with you. First of all, thank you very much to Professor Wahab to introduce you with us. And regarding with your experiences in meteorology, I think you have been work on behalf of Alexandra International Airport, Met Office. Not yes. In Alexandra Airlines. Sorry for our misspelling errors for this. We will do immediate correction onto the panel programs. Rokaya will present a paper on the assessment of reanalysis data sets against radiosonde observations over Eastern Mediterranean region. This is one of the collaborative work together with Mrs. Salah, Professor Wahab, and yourself. So, and also Said Robea. So please, it is your turn. Please, you can share your screen. Thank you very much.
You can see my screen now?
Yes, we can see your screen. Thank you, Mrs. Hassan.
Okay. Thank you, Professor Aslan, for introducing me, and it's an honor to be with you today. Today I will present one part of my PhD thesis, which is the assessment of reanalysis data sets against radiosonde observation over Eastern Mediterranean region. Aim of this study is to assess the accuracy between ERA 5 and ERA interim against radiosonde.
Excuse me, Mrs. Hassan. Yeah, it's okay now. Thank you.
You can hear me right? Okay. Aim of this study, we have a lack of station, especially upper air station. So we assess the accuracy of ERA 5 and ERA interim against upper air sounding we used the period from 2000 to 2017. Meteorological variable we used is geopotential height, air temperature, and dew point temperature, and relative humidity. We apply on 9 stations for 4 isobaric level, 815, 700, 500, and 200 hectopascal. In this study, we also study the impact of North Atlantic Oscillation Index on upper air temperature and surface temperature. We choose 9 stations from 4 countries according with different climatology according to Köppen classification. Data and methodology. Data we used is the observed daily radiosonde data, era interim, era 5, and North Atlantic Oscillation. The methods we used a statistical method to assess these types of data. Pearson correlation coefficient, mean bias, root mean square error, and the Taylor diagram. Spearman correlation used to compare between surface and upper air temperature and North Atlantic Oscillation Index, because it depends on rank, not on the raw data. The results, here we can see the vertical profile of correlation coefficient between era interim, era 5 with observation data for geopotential height, temperature, and dew point temperature and relative humidity. We can see the correlation between the observed and reanalysis data is very strong. It's above 0.9, and it increases with altitude, for geopotential, and also it's strong correlation with temperature. In case of dew point and relative humidity, we can see the profile is resembled for dew point temperature and relative humidity. It's very strong at lower level, and when we reach to 500 hectopascal, it becomes to decrease upward. Here we can see the vertical profile, but here for the mean bias between reanalysis data and observation, we can see in case of geopotential height, the mean bias is very low at lower altitude, and the bias increase with altitude. In temperature, the bias is very small, but it becomes less with altitude. In case of dew point temperature and relative humidity, the bias increase with latitude, and we found that the coastal stations has underestimated, but the other station had overestimated of the values of relative humidity and dew point temperature. We also used Taylor diagram in order to illustrate the similarity and variability and dispersion by comparison, correlation, and standard deviation. Here we can use Taylor diagram for geopotential height at different isobaric levels, and we can see 2 reanalysis, era 5 and era interim, have strong correlation with reference around 1, so it can be good comparison between reanalysis and observation. It's similar for temperature. It has strong correlation above 0.9 for all levels and around reference 1, which is the standard deviation normalization. But in dew point temperature and relative humidity, we can see that dispersion and the correlation decreases when we reach to upper atmosphere at 200 hectopascal. In humidity, we can see at upper atmosphere, the reference increase with, and we can see no points at 200 hectopascal. For the correlation between temperature and North Atlantic Oscillation, we can use the correlation in both summer and winter. Correlation are negative from surface till 200 hectopascal, then it turned to positive at 200 hectopascal. With some exception, for some station, it remains negative correlation at all levels. Conclusion, we can see from results we reached till now that ERA Inter and ERA 5Al is variable source for data and can be used to supplement and replace the radiosonde data and compensate for the lack of direct observation in and around Eastern Mediterranean region, because in Egypt we have only 6 stations, we need more, so we can, from our result, we can compensate this lack of station with using reanalysis data. And in general, negative relationship between atmospheric circulation with North Atlantic oscillation with surface and upper air temperature at all stations up to middle troposphere at 500 hectopascal, turning to negative, to positive, sorry, in upper troposphere at 200 hectopascal. Thank you for your attention.
Dear Mrs. Hassan, thank you very much for your information about the real applications, near vicinity of your country and specific area.